Thank you so much, Ernest. My name is Tim McNamara. This is Unpacking Unsafe, just in case you went to the wrong room. Otherwise, we might call this the title slide. So I'm just waiting for it to come on screen. What we're going to be talking about today is memory safety. And in particular, this idea that I'm not a Rust expert, and there's this kind of dark, dangerous corner, unsafe, that I've been warned about. Like that's for like real Rust programmers. And what I want to do is demonstrate how people actually end up using this in the Rust community, and how you as a maintainer of a library or an application can review code that might even contain unsafe, and whether or not this is something that you might need to consider. So, my name is Tim McNamara. I'm from a small, strange country, often left off the map, called New Zealand. I run a technology consultancy called Accelerant. My lead brand is this thing called Tim Clicks. And I'm on the planet to build a better planet. I genuinely believe that Rust can step software forward. And some of the most critical problems that we face today as a society that is digitally connected and has software inside the fabric of everything we do requires a continual focus on reliability and security. You are very welcome to go and find me online. This is my book. One of the interesting things about Rust in Action is that it will actually enable you to build real applications. And we do actually talk about a few things like, how do we use this? Well, what does unsafe even mean? And so that's the plug for the book. The agenda today is pretty straightforward. Here's not many people like watching a 90-minute presentation, or a 55-minute whatever. So here's kind of the 90-second version. We use Rust, even though it might be difficult, it might be hard to learn, because it's supposed to be memory safe. But there is kind of this ability for us to sort of unlock the keys somehow. What does this mean? We've got this unsafe keyword, and it turns out that about 96% of all downloads from crates.io will have unsafe in their dependency tree. So saying we don't have unsafe in our code doesn't mean that your dependency or your dependency's dependency excludes unsafe. So it's still part of your job to understand enough to be able to go and check. And this is sort of we're going to wrap up towards the end. So I just want to start. I have 3 little girls, and we spend a lot of time watching Bluey. And one of the episodes is called The Fairy Tale. Bandit is the dad. He's talking to his 2 daughters, Bluey and I've forgotten her name, Bingo, about a fairy tale land called the 80s. And in the 80s, they didn't need safety vests. They didn't need hard hats. We're not in the 80s of software anymore. We actually need better tools. And this quote didn't work very well. If you have a very large code base, let's say 1 million lines or more, at least two-thirds of your security vulnerabilities are going to be due to memory safety concerns. This has been independently corroborated by multiple places. And Rust is a very, very good way out of this, except for the fact that unsafe exists. Now, there's a problem, because culturally, the Rust community is allergic to unsafe. So here is a report from 2020 where the lead maintainer of the Actix web framework, which at the time was the highest performing web framework in the world, and was essentially put up in a pedestal as one of the lead Rust projects, says, I'm done, I'm out. And the reason why this happened was because the Actix web framework was created on sort of an internal system called Actix, and Actix was an actor-based system which enabled, so it's a sort of pre-async Rust, enabled people to kind of create a little worker that cooperated with the other workers that are all operating at the same time to perform requests and responses. Nikolai Kim was a staff member at Microsoft, but he did this on his own time and received a huge amount of vitriol because of the use of unsafe constructs. Now, it turns out, and so the response was like, I've checked it, I'm good enough. Like I went in, I'm sure that this is okay. It's like, no, it's not okay it's not okay for the peak Rust system to heavily rely on unsafe. This is actually not very good for the Rust community. And so kind of you have this tension between the maintainer and between the ecosystem, and it turns out that the ecosystem was right. There were soundness flaws in the implementation. So let's talk about what unsafe actually unlocks. Less than you might think. So here is, some ordinary Rust code, and what I want to do is kind of dig into it and say, here's a pointer to the first element. And I take A, or let's say a reference to A, and I want to cast this as a mutable pointer to an i32. And that's fine. And I'll just go down to, so this is a memory address. We can figure this out by taking pointer 1 and asking for a memory address. And I can, when we get an error. Casting and, that I can't do. I thought this was fine. Okay, well, I'll just do this as pointer. Yeah, we'll try this. Aha! So Rust compiler is actually going to be a little bit smarter already. We can't just kind of wildly cast references around. That's kind of nice. And I'll just run this code. We receive a memory address as output. That's great. And so we don't need unsafe to access a pointer. To create a pointer. And it's like, for whatever reason, I need 2 vectors. I want one that has 1, 2, 3, and one for whatever reason is 2 and 3. So let's go and increment my pointer. I'll need to do something fun, which is cast it as a usize. So it's just live coding is actually quite hard when you're on stage. It's quite prone to sort of typos and things. It's kind of intimidating, really. And I just want, actually we'll define this as mutable and then increment by 4. We need to increment by 4 because that's the width of an integer of i32. And now we can build up a vector from raw parts. And pointer 1, where does this point to? It points to the number 2 in the heap. The length field we can just define as 2. In fact, I'm going to sneak, I'm going to say it's a length minus 1, because I want type safety. Duh. Capacity. minus 1. So I'm totally safe here. And we can even, we get a compiler error. This operation is unsafe and requires an unsafe functional block. Okay, I'll do that. So I'll create, I've gone and created a second cursor, which is also helpful. B is unsafe. And I can actually print out B. Well, let's find out. Will this work? Matching closing delimiter. Actually, I can fix that. That's a typo. Ah, superb. This is why this is called mob coding. It's like unmatched types. I found a use case. Okay, so I'll cast this as a mutable pointer back to an I32. I don't have access. There we are. Love you all. And goodness gracious. Okay, so just in case anyone doesn't know Rust. Oh, it doesn't have a display. Okay, fine. Okay, Rust. Thank you, I appreciate it. Cargo, oh no, we'll hit run here. 2, 3, perfect. Is it a free invalid pointer? What? Maybe I'll just turn off all the rules. I'll just use release mode. And I'll just use it. So here we go. It's package bin A. Copy. Close this down. Run release bin A. Core dumped. So what have I done? Why is this wrong?
You're dropping the vector twice.
We are dropping the vector twice. This is implicit in our code. What we've introduced is a memory safety vulnerability, unsoundness called a double free. Rust at the end of an object's lifetime will delete the value or invoke the drop trait. It does this for A and says at A, when A gets to the end, when it is no longer available, on 13, it is dropped. But I also then drop B. The reason why it does it twice is because I have told Rust that I will comply with its rules. Unsafe enables you to tell Rust that you have complied with its ownership and lifetime rules with pointers. That's all that you get. You still need to make sure, you still have a type system. We can't do something like put a float in here. You know, the length is 2.0. You still have a compiler. It's still going to make sure that you are doing the right thing. The unsafe keyword only unlocks a tiny slither of extra behavior. It pushes the burden from the compiler to you. It pushes the burden from the internal machinery or the logic analysis system inside the compiler to your brain. And because there are many things because your Rust program exists inside the context of other software, we might have to interact with the operating system. The operating system can really only give back a pointer and a length in the same way that I've kind of magically created a pointer and a length. By the way, we don't need to do for. I could use size of, and I'll get a warning about using an intrinsic, but there's actually, I think it's in standard memory. Size of a type, I32. So, and the other thing is that I don't actually need addition or casting to casting to integers to increment things. In fact, the authors of the standard library, not the standard library, maybe it was detected that this was a relatively common pattern of when you do have a pointer and you need to kind of do increments and offsets and so forth, and they thought, you know what we should do is just add an API to safely offset your pointer so you don't need to do any of this yourself. And what I am interested in kind of investigating, or the kind of the research that went into this talk, looked at, given use of unsafe, and then detection, can we detect other patterns that could be pushed into the standard library? Are there other things that we could make safe? There's another one, a couple of others actually, but this one is probably the best. So I've got one string and two variables, but I have a compiler error. What's gone wrong?
String is not copy.
A string is not copy, but that doesn't make any sense if you are in your first 20 minutes of Rust. Neither does we have moved the value. No, reasonable programming languages like a Python or a JavaScript, this is perfectly acceptable. So what has happened here is that, so we're technically correct, and this is the problem that we as people that go to Rust conferences have when we try to communicate with people that do not. We say things that are, they use English words, but they have such a technical meaning that they're just completely incomprehensible. String does not implement copy. And even if it did, we probably, so what this is meaning, so we create a second variable. The let keyword will shift ownership to B. Rust will refuse the access to A on line 5, because if we really intended to access A again, we need to re-borrow from B. It's like, aha, but I had unsafe. And it's like, what I'm sort of saying is like, well, Rust, you think you know what you're talking about, but I wanted two variables. I really like having two variables. And sadly for me, the ownership rules still apply, even inside unsafe blocks. You do not get access to just kind of this crazy kind of free-for-all world. Unsafe is very limited in its capabilities. That's the big message. The idea is that, there's a couple of things. One, unsafe is not this kind of dangerous, crazy world. It is tractable. It is learnable. Secondly, you want to restrict the amount of cognitive complexity. You want to restrict the size of your unsafe blocks to the minimum amount possible, so that you only need to verify the minimum number of blocks of code. Let me go back to my slides. The reason why I think that it's quite important to shrink unsafe blocks is because they're significantly easier to review. Here is an example. We've got a comment that says that the team member has asserted that current is sum. Therefore, by implication, this bump thing does the right thing. Okay, this is another instance of so we've created a box that is a trait object that implements error. And we are, for whatever reason, doing this with raw pointers. Okay. But it's conceptually understandable what's going on. And it's possible, though, you could argue that this is already too big. You don't need to use unsafe to create raw pointers. You only need unsafe when you actually go to either access them or dereference them. Here we have inline assembly. Inline assembly does require unsafe blocks, but you still get things like type safety. Rust will ensure that, also the Rust compiler will ensure that the right parameters are actually being sent in, and for example, the right bit widths to be able to satisfy the assembly. But this is pretty understandable if you read Intel or whichever flavor of assembly you prefer. We have an interaction here with the native operating system. It exports some library which defines its own string type. And so there needs to be an interface between the native library or something else, NS string, and Rust. Okay, I'm getting a bit boring, apologies. And then we get stuff like this. This is dangerous, in my view, because it's much harder to understand why someone has used an unsafe block around the whole thing. We want to ask Rust to do as much work as possible. Clippy is a better programmer than me. Thanks, Andre.
It's better than me too.
And by the time we get to stuff like this, it's very hard to know sort of what's going on. So we kind of have this intuition that smaller is better, and we want very, very narrow use. And also, it's really nice to have documentation saying which invariants have been, so which preconditions have actually been already provided. Let me talk about some of the empirical research that I have done. It is in a repository. Well, it will be in a repository that is in the very last slide. Turns out that there's this weird thing called open source, and we can just go and download every crate on crates.io. And every crate describes its own dependencies. So we have a graph of about 137,000 crates and about 700,000 edges in the graph. Oh, apologies for the typographical mistake. This is last-minute editing going badly. Of 300, so about 25,000 use unsafe blocks. And another 15 include that through their transitive dependency graph. So, okay, not too bad. Right? So essentially, if we were to audit everything, we would only need to audit, let's say, 25,000, which is, and then actually, it gets a little bit, or at least it seems to get a little bit better. Inside, 50% of those 15,000 actually use only 6 blocks in their whole thing. So that's okay. That's kind of auditable. But the 100th percentile is 79,000. When you start getting machine-generated code, and code that has been code-generated from, let's say, C header files, compilers like unsafe. It's very easy. And so most of this stuff is like, yes, kind of easy-ish, but yeah, 100% at 79,000, it's kind of, oh, gosh. And there is actually one problem, though. So this is looking okay. But if Rust is a social organism or is a social network, one of the characteristics of a social network is that it obeys a power law distribution. A very small number of crates are extremely important. Therefore, of the now 59, nearly 60 billion downloads, only 4% have no unsafe in their dependency graph. This means that it is suddenly part of your responsibility as someone who is advocating for Rust at work to have a plan for saying, we know how to check. Because it's almost impossible for, I say almost impossible, you know, like 4%. It's not quite impossible, but it's very unlikely that you're free from unsafe. This is something that is present in your code even when it's not present in your code. I wish to introduce Cargo Vet. You don't need to go alone. A Cargo Vet is a tool which enables you to participate in a community of verifying specific versions of code. It's like, oh, yeah, we've invested 3 hours of reviewing its 6 unsafe blocks, and we think it's okay. And you can essentially upload your report or submit a pull request into a GitHub repository, and other people can opt in to thinking that you are a credible person. And you, as the author of an application, are able to say that I have certain people that I trust and people that maybe I trust less. And then there is a little bit of tooling for it's not little, sorry. There is tooling for this audit process to be integrated into your build system. It's not perfect. It definitely relies on humans doing the right thing. And you should be skeptical. Because it's your business, literally, it's your users that will pay the price for you deciding to just ignore things without consideration. And how do we do this? The top is the install instructions, and the bottom box is the usage instructions. So the cargo install, it's just a cargo subcommand, and inside your package, or inside your crate, you first need to provide some initialization, which will set up a configuration file which says, these are the people that I trust. Let's go have a look. That took a while. In this case, I actually am not really depending on anybody. My cargo.toml is exceptionally boring because I've just got a couple of snippets here. So I'm just going to cargo add Serde. Features derived. This will probably take about 4 years to download. Cargo vet. Oops. We didn't get a safe, we didn't actually pass. You need to do a little bit of work to tell the tool what you care about. And so this demonstrates that there is some work to do to say that for specific versions of my specific dependencies, I do trust them. But at least the tool is there. And then lastly, I also wish to introduce Miri. Miri is an interpreter for the medium representation or the internal representation within Rust. So it's sort of like and it's like, that sounds very, very abstract. Excuse me. Just sort of demonstrate how to install it. It's a little bit scary because it requires nightly. It is installed via ruststop. And here we are. Install nightly component Miri. Not every nightly has every tool installed, and so if you're doing this on the command line, sometimes it can just say, I don't have Miri today. And there are various workarounds, but essentially the workaround is, okay, well, maybe just go to yesterday's nightly, or pick a specific version that you do care about. And now, later on, I can call cargo Miri test or cargo run, and your program will be run inside the Miri world, where it has full control over memory allocations and so forth, and we get a very interesting report. So allow me to look at the program that we just created, where I sort of said, yeah, of course it's unsafe. No, it's not. I can just use manual. Sorry. So here's our original program. And we wanted to check whether or not this use of unsafe, this block, we don't really know if our block B is safe. and we wish to verify this. So cargo plus nightly will ask for the nightly, sort of enable nightly features. We run, and then I have this binary A. There is a little bit of preparation. Mary kind of sets up its own environment. And then there is quite an extensive report. And it says, no, this is not safe. It actually does something that's a little bit better that I really want to show off, and that it is warning you that you are performing an operation. In this case, we are casting from an integer to a pointer that will decrease its ability to reason. So if you read through the garbage in front of you, you will see that this helpline in the middle, the implications of, implications of doing this, sorry, my computer is deciding to heat up, is that you may if you cast from integers to pointers, Miri may miss bugs because it doesn't have the provenance information. So please use a different API. But here is the actual compiler error. It's that you have some undefined behavior during the deallocation. You're actually not pointing to the start of a span of memory that you care about. And therefore, Miri has guarded us against pushing unsafe code to production. This is a tool that you can integrate into your CI systems, and it will work through your it will actually essentially push through your dependencies because it is running it against the compiled binary. And so you don't need to be an expert here, but you're able to give yourself a little bit of knowledge to at least put some guards in place to say, okay, let's check. And if there is a problem, well, we're going to need to ask for help. Or at least we file an issue. We do whatever we need to do to go to the next step. You go to my GitHub page, which is actually easiest to find. It's timclicks/tutorials. You'll find this the unpacking unsafe repository as well as these example code bases. And with that, I wish to say thank you very much for hosting me here. Hope this has been a really fun and enlightening talk. Cheers.